In this unit, we're going to learn linear inequality. Linear inequality is very much like linear equations, so I want you to copy this down by pressing pause on the video. So linear inequality is similar to linear equation, but uses an inequality symbol. So inequality symbol, remember these symbols that we talked about, less than or equal to, greater than, or greater or equal to. And the solution to a linear equation, unlike equation, there's usually one solution or no solution or undefined. Linear inequality solution usually is all the ordered pairs that make the inequality true. So it could be many solutions, and we'll see that in our examples below. Okay, so here's one example. Determine which ordered pairs are solutions to the linear inequality below. So I have x being 2, y being 5. So I have to plug it in. I have 2x minus 3y here. So if I plug it in, 2x is 2 times 2 minus 3y, y is 5. And that should be greater, or that should be less than 15. So let's see if this is true. 2 times 2 is 4. 3 times 5 is 15. So it looks like I have negative 11, and obviously it's less than 15. So yes, the answer is this pair is a solution. Okay, and now try the second one. I'll change the color. If I plug in x, 2x is 2 times negative 1. So I'm using parentheses to protect my negative signs, and y is negative 7. So is it less than positive 15? I have negative 2 minus 3 minus 21. So I should have, if I copy down the rest of it, double negative makes a positive, and I end up having 19 is less than 15. Not a true statement, so because it's false and this pair cannot make this inequality true, therefore this pair does not meet the standards of being the solution to this inequality. They are not solutions to the inequality. Okay, so try number 3 and try number 4. I will give you the answer here. And number 3 should be no. Number 4 is yes, but you need to demonstrate the steps to me. Okay, so now go back to the first day when we started the solving linear equations. We started with solving, right? We started with graphing. Same thing here. How do we solve linear inequalities? By graphing. So first of all, we still have to put the inequality into, oops, I cannot spell. Into a slope intercept form. And just be careful that you have to flip the inequality sign if you multiply or divide by a negative number, and I'm sure we'll come across that. So now we have to graph the line. We use a solid line for less or equal to or greater or equal to. So as long as I have the equal sign underneath there, I have to have a solid line. Otherwise, we use a dotted line to indicate that those points are not included in the less or equal to statement, a less or greater than statement. So here's an example. Oh, then we have to shade above for greater or greater than, and shade below that line, whether it's solid or dotted line, for less or less than. So here we go. If we have to solve this for a slope-intercept form, we have to subtract 2x on both sides. I have negative 3y less than negative 2x plus 15. Now I divide by -3 under every term. And be careful when I divide that, because it's a negative, right? I have to flip the signs. So on the left hand side I have y, on the right hand side I have 2/3x minus 5 in this case. So because it is a greater than, so the line has to be a dotted one, and then because it's greater, it has to be the area shaded above. So let's graph this. My y-intercept is -5. 1, 2, 3, 4, 5. It's here. -5 on the B. And then my slope is 2/3. So I rise by 2, I run by 3. And that's how I form this line. But I have to be careful that this line is a dotted line because I don't have the equal sign there. Okay? And then I'm telling you everything above here, all the ordered pairs in this area above the line satisfies the inequality. So for example, let's take an easy example. This point here, 0, 0. If I plug it in, I have 2x minus 3y should be less than 15. 2x is 2 times 0 minus 3 times 0 should be less than 15. I have 0 minus 0. Obviously, 0 is less than 15. This is right. But if I take any point south or below that dotted line, that will make that inequality statement a false one. Therefore, they're not part of the solution. Okay? Okay, I'm going to demonstrate number 2. The equation is already in a in a slope-intercept form with b equals -1, right? And slope is, so b is -1. Slope is -2, therefore it's rising to run by -1. Now, be careful here. I have a less than or inequality. So less than, it has to be below that line. And then I have equal, so it must be solid. So if I connect the dots here, at this time I have a solid line this way. And if I have that, because it's less than everything below that line, those ordered pairs are my solution. Make sense? Yep. And let me see, I will do number 6. And this time it requires me to maneuver the original equation to rewrite it into slope-intercept form. So I'm going to do that by subtracting 3x on both sides. And then I would end up having 2y less than -3x plus 0. So I don't need to write the 0. And then I divide 2 on both sides. Oops, sorry. Yeah, it's really easy to make mistake. You have to stay concentrated. You notice that I have to talk while doing, while thinking. So that's how I made that mistake. So now I have my y-intercept equals 0, which is right here. My slope is -3/2. So I have to rise by 3. I run negative by 2. That's my line. And now notice that what do I have here? I have less than, so it must be below. And I have no equal sign, so it's dotted line. So then now I can connect these 2 points by using a dotted line, right? That's my inequality right here because it's less than, it's all below. Okay, 2 special cases. Number 7, y is less than or equal to -4. So before I start, I know this has to be a solid line, and then it's below, right? So y equals -4 is 1, 2, 3, 4 is here. That's -4. And because it's a solid line, I know it's it has to look like this. And plus there's no x terms, right? It doesn't tell me x can be anything. It doesn't affect this. And then guess what? Where is y is less than or equal to -4? Obviously, it's everything below that. That's it. So it's fairly easy. But when you first look at it, you're looking for the x. You're like, where is the x? Same thing with number 8. X is greater than 7. In this case, this has to be above, and it has to be a dotted line. So we find 7. 7 should be x equals 7 is here. And x, because it's a dotted line, x equals 7 looks like this, right? But where is x is greater than 7? Everything beyond this point is greater than 7. Anything to the left is less than 7. So in this case, we call it above. It's really to the right-hand side. Okay, so that's the concept. It's not hard at all, but it's good practice. Make sure you fill out the sheet, work through all the other practice problems in class. All right, guys, I'll see you soon. Bye.